We know about a Y-intercept, right? We've been talking about that. It's in slope-intercept form. However, every graph, every linear equation, let me adjust that. Not every graph, but every linear equation has two intercepts. There is a Y-intercept and there is a, what do you think? The X-intercept, yeah. Because there is a place where every line crosses both the Y-axis and the X-axis. So today we're going to be graphing based off of the Y-intercept and the X-intercept, where the line crosses the Y-axis and the X-axis. So just a quick review. The point at which the line intersects the X-axis, it is called the X-intercept. So I'm going to try to do this without making it too crazy with the lines, but the X-intercept would be right here. There it is. Oops, let me move this up so you can actually see what I'm doing. So there is the X-intercept right there. The point at which the line intersects the Y-axis is called the Y-intercept. That would be this one right up here. So the example here is to identify the X-intercept and the Y-intercept. So we've pointed to them, but let's go ahead and say what they actually are. So the X-intercept, we can abbreviate that XINT, and I'm not going to do dot dot. I'm going to say equals. How far over is it? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8. The X-intercept is at 8, which, if we're talking about an ordered pair, would be the point 8, 0 on the graph. Right? If we're using both X and Y coordinates, an X-intercept of 8 would mean a point of 8, 0. Does that make sense? We okay with that? Hopefully. All right. And then the Y-intercept, let's figure that one out. What's the Y-intercept on this one? How far up is this? Count those spaces and let me know. I feel like it's, yeah, I was gonna say, I feel like it's the same as the X-intercept. So it's, if you count up 8, then the Y-intercept is also 8. So the X-intercept is 8, the Y-intercept is 8. However, the coordinate for the X-intercept versus the Y-intercept are a little bit different. This one is 0, 8, as opposed to 8, 0. Because the X-intercept references the X coordinate, and the Y-intercept references the Y coordinate. Now, what do you notice about the opposite coordinates on each of these? So the X-intercept is 8, the X coordinate is 8. What's the Y coordinate for this one? All right, on the Y-intercept, the Y coordinate is 8. What's the X coordinate? 0, okay. So on a graph, the intercepts exist when the opposite coordinate is equal to 0. So for a Y-intercept, the X coordinate is 0. For an X-intercept, the Y coordinate is 0. So what we're going to do today is a little bit of algebra. So you can see the next thing right here. It says finding intercepts algebraically. To find the X-intercept of an equation, that's this first one. What is the Y coordinate for an X-intercept? 0. So what we're going to do mathematically and algebraically, we're going to do that in this first little example down here in just a moment. But we're going to write some things down first. We're going to say set Y equal to 0 and solve for X. Set Y equal to 0 and solve for X. So basically, if you have an equation and you're trying to figure out an X-intercept or a Y-intercept, you're going to plug in 0 for one of those two variables, and then you're going to solve for the other variable using a little bit of algebra. To find the Y-intercept, do you think anybody can tell me what we're going to write for this sentence? Same but reverse, exactly. We're going to say set X equal to 0 and solve for Y. All right. Now, sometimes this is a really convenient way of graphing something. Sometimes it's not. I'll tell you about when it is a good idea and when it's not a good idea. But let's go ahead and do some practice on this. So the first 6 examples, there's no graphing. It's just using a little bit of algebra. And then we got 4 examples at the end where we're going to do some graphing. So problem number 1. Or not problem number 1. Let's just do this example right here. Sorry. Find the x and the y-intercept of the equation y equals 3x plus 6. So let's do the x-intercept first because those are the instructions we wrote first. So x-intercept. We are going to do what? We're going to set y equal to 0 and then solve for x. So what that means is instead of writing y equals 3x plus 6, so I'll just write the equation here for a second. Y equals 3x plus 6. We are going to write 0 equals 3x plus 6. Because the directions tell us right here, set y equal to 0 and solve for x. So I'm going to replace y with that number 0. And then I'm going to use a little bit of algebra to solve for the x variable, which is going to be 2 steps. We have a 2-step equation that we have to solve for. Are there any questions so far? Any questions about what we just did? All right, so we're just replacing y with 0, and now we have to get x by itself, so we have to solve for it. So if we're using algebra to solve for this, what's the first step we need to do to get x by itself here? Subtract the 6, yeah. We want to get x by itself, so we have to move everything away from x. So subtract 6, subtract 6. Those are going to cancel. 0 minus 6 is negative 6. That's going to equal 3x because that's what's left over here. Okay. What's our next step? We have one more step. How do we get x by itself? One more step. What do we need to do? Divide by 3. Good. Negative 6 divided by 3 is negative 2. So the x-intercept is negative 2. And if we're talking about coordinates on a graph, that would be the point negative 2, 0. All right, so that's the quick little algebra we can use to get the x-intercept. Now, if we need the y-intercept, we're going to do the same thing. However, instead of replacing y with 0, we are going to replace x with 0. So we had our x-intercept. Now it's time for the y-intercept. We're going to use the same equation, y equals 3x plus 6. But instead of swapping out y and replacing it with 0, we're going to swap out x and replace it with 0. So that would be y equals 3 times 0 plus 6. This one's going to be easier because this one doesn't actually involve any algebra. What does 3 times 0 equal? What's 0 plus 6? 6. So there we go, y equals 6. Which means that the coordinate would be the point 0, 6. So we could place both of those points on a graph and then just draw a line between them and get our line. So we were able to do this without using the slope or the y-intercept. However, I still think it would be easier to use slope-intercept form for graphing this because it's already in slope-intercept form. So we've got a slope of 3 over 1 and a y-intercept of 6. The point of what we're doing right now is just to practice plugging in for 0 and solving for y and plugging in for 0 and solving for x. In terms of graphing, the most useful form to use intercepts with graphing is standard form, which is why when we actually get to the graphing problems today, you'll notice that all 4 of those problems are in standard form to begin with. Because if it's in slope-intercept form to begin with, there's no real point of using this to graph your line. This is just a way to practice what we're doing right now. All right. Are there any questions before we look at some more examples. All right, so the next three, these are all starting in slope-intercept form. The three after that are in standard form, and then the very final four that we're going to graph are also in standard form. So here we go. Problem number 1. Let's go ahead and do this. The X-intercept. We are going to set y equal to 0. So substitute out y, replace it with 0, and solve for x. So this y is going away, and we're replacing it with 0. So we're going to say 0 equals. I'm going to write negative 1x and then plus 5. So again, if you have a negative next to a variable, it's always a good idea to put a negative 1 with it, just to make it a little bit easier to see what's going on with it. So this is the equation that we're writing. We replaced y with the number 0, and now we solve for x. So what do we do first? Subtract 5. Good. So subtract 5 from both sides. 0 minus 5 is negative 5, and that equals negative 1x. Yeah, take fast. So negative 5 equals negative 1x. What do we do next? Divide by the negative 1. All right. And so x equals, what does negative 5 divided by negative 1 equal? Positive 5. Good. So our x-intercept is 5, which gives us a coordinate over here. We're just going to write the answer over here. The coordinate for that would be the point 5, 0. If x is 5, the x coordinate is 5, and the y coordinate is 0. And a good way to remember that in terms of writing this answer over here is right here it says x is 5. So the first number in the parentheses needs to be that in an x-intercept. And we know that y has to be 0 because we wrote that up here. Y is equal to 0. So this 0 is the same as that 0. And this 5 is the same as that 5. It's the point 5, 0. All right, let's try the same thing for the y-intercept. Instead of swapping out y for 0 this time, we're swapping out x for 0. So we're going to say y equals negative and then 0 in parentheses and then plus 5. This might be the easiest problem that you do all day. What's the answer? 5, yeah. Negative times 0, that's not anything, that's 0. 0 plus 5 is 5, so y equals 5. So that would be the point. Let's put this over here, 0, 5. So we got an x-intercept of 5, 0, a y-intercept of 0, 5. All right. I want you to try the next two on your own. I'm going to give you, what's that? Can we try one of these here? Okay, yeah. We'll do one of the fractions together. And then I'll have you do 3 on your own. How about that? Okay. So that's a fair request. Let's see. X-intercept. We're replacing y with 0, and we're solving for x. So we're going to say 0 equals 1/2 times x minus 8. And when we do that, we're going to start by doing what? What's our first step here? What are we doing first on this for number 2? Take away the negative 8. What's the opposite of subtracting 8? Adding 8. So plus 8 to both sides. So that means 8 equals 1/2 times x. Now, how do we get rid of a fraction that is right next to a variable? How do you get rid of a fraction that's multiplying by a variable? Anybody remember? Yep, we're gonna flip the fraction and multiply both sides by that. So we multiply both sides by the reciprocal of the fraction. So instead of 1/2, we're going to multiply both sides by 2/1. So times by 2/1 there, and then multiply by 2/1 over here. And the reason for that is we can cross cancel on the right-hand side. The 1s and the 2s cross cancel, leaving us with just x. And then 2 times 8 is 16 over 1 is just 16 over 1, which is still just 16. So x equals 16. So the coordinates for the x-intercept would be 16, comma, 0. Now finding the y-intercept is going to be easier because we're plugging in 0 for x on this next one and then solving for y. So the y-intercept is going to be y equals 1 over 2 times 0 minus 8. 0 times anything is 0, so 1/2 times 0 is 0. 0 minus 8 is negative 8, so y equals negative 8. So the y-intercept is 0, negative 8. No algebra was needed on that. All right, so try number 3. And then when you are solving for your first one, when you're solving for the x-intercept, your last step is going to be multiplying both sides by the reciprocal of that fraction. You're not going to make it positive though. So you're going to multiply by negative 3 over 4. So make sure it's still a negative when you multiply both sides by that on number 3. So take a couple minutes on that and we'll check back in and see what you get for your x-intercept and your y-intercept. And if you have questions as you're doing this, let me know. And by the way, the answers do not have to be whole numbers. Just as a heads up on that, they do not have to be whole number answers. Good question. So if you end up with a fraction as your answer, if it's an improper fraction, leave it as an improper fraction, but just reduce it. You don't need to worry about making it an answer. Good question. That's a bit of a hint for your x-intercept on number 3. All right, let's start with the y-intercept on this one. What's the y-intercept? I think that's easier to do than the x-intercept. Let's start with the simpler one. What does the y-intercept equal on number 3? Anybody have it? 2. Good. So the answer is 2 because negative 4/3 times 0 is 0 because anything times 0 is 0 and 0 plus 2 is 2. So the y-intercept is 2. So that's the point 0, comma 2. All right. That one's done. What about the x-intercept? Does anybody have an answer for that they'd be willing to share? Ash, what do you have? 3 over 2? Yeah? Do we agree with that? Any people who've solved that one, do we agree with 3 over 2 for x? I see some nodding. Good. All right. I also agree with that. So let's take a look. First thing we're going to do, subtract 2 from both sides of the equation to get rid of the positive 2 over there. On the left-hand side, 0 minus 2 is negative 2, and that's going to equal negative 4 over 3 times x. Now, in order to get rid of the fraction that is multiplying by our variable, we have to multiply both sides by the reciprocal of that fraction, which is -3/4. So we're going to multiply by -3/4 on both sides. And that -2, I'm just going to put a 1 underneath it just to remind myself when I multiply fractions, it's straight across the numerator and straight across the denominator. The 4s and the 3s, those all cancel out on the right. And that gives me x. And then over here, -3 times -2 is +6. 4 times 1 is 4. So that's 6/4. However, 6/4 reduces to 3/2 because these can each be divided by 2. So x equals 3/2. If you can reduce a fraction, reduce the fraction. This one does not turn into a whole number. And I'll talk about this in just a second. Let's get this on here. So we got 3/2 and then comma 0. Now, in terms of graphing, example number 1 up here, 5005. Example 2 here, 1600, -8. Those are both really good uses of x-intercepts and y-intercepts in order to put those on a graph. Question, Karen, or just stretching? What's that? Good? Okay. So these first two examples would be perfectly fine if you were graphing, because those are nice, clear points on the graph. However, with number 3, thank you. With number 3, the y-intercept is a great point on the graph. However, the x-intercept is not ideal. And the reason for that is, if we were to have a graph, finding 3 halves on the x-intercept would be an estimate. It would not be an exact location. Whenever you're putting points on a graph, if you can be exact, you should be exact. So number 3 was written in slope-intercept form. I would highly recommend, if you were graphing this, not to do it this way. The reason why you're seeing it this way is just to know that you can do it this way, but it is not the most efficient way if you're trying to get it on a graph going from slope-intercept form. Going from standard form is usually the way that you would use x-intercepts and y-intercepts. So let's go to the second page here, starting with problem number 4. So when I was in school, the only way that was taught with using x-intercepts and y-intercepts was with standard form. And the reason is because it's more useful than slope-intercept form. But I really like this lesson the way it's structured, because you can use it with anything. You can use it with slope-intercept. You can use it with any xy equation for that matter. It doesn't even have to be in a particular form. So starting with number 4 here, you'll notice that these are all in standard form. The x and the y's are on the same side, and then we have a regular number on the other side. And we're going to do the same thing that we did on the first page of notes here. It's just going to look a little bit different because the x's and the y's are on the same side. So the directions for solving are going to be the same. So for the x-intercept, we're going to set y equal to 0. We're going to plug in 0 for y. And we're going to solve for x. So we're going to say x minus 0 equals 2. Because we're plugging in 0 for y. So the substitution is no different. The equation looks different because it's a different form of a linear equation, but the idea is the same. Substitute in 0 for one of the letters, solve for the other. So what do we get for the x-intercept? Two, yeah. X minus 0 is just x. So x equals 2. So the x-intercept is the point 2, 0. All right, the y-intercept is going to be zero minus, I'm going to put a 1 with it, 0 minus 1y equals 2. So on the left side of the equation here, 0 minus 1y is just negative 1y. The 0 doesn't actually need to be there. So we'll say negative 1y equals 2. Okay. We have to do one thing here in order to get y by itself. What do we have to do? Yeah, divide by negative 1. And the y's cancel out, and 2 divided by negative 1 is negative 2. So the y-intercept is negative 2. X-intercept positive 2, y-intercept negative 2. Would be 0, comma, negative 2. In fact, when it is written in standard form, when the equation is written in standard form, you don't actually have to put in the number 0 to begin with. Here's what I mean. For number 5, you got 3x minus 2y equals 12. For the x-intercept, we are replacing y with 0. But if you plug in a 0 for y here, what happens to negative 2 times 0? What does that equal? It just goes away. Yeah, it just basically goes away because negative 2 times 0 is 0. So if you replace y with 0, the negative 2y goes away entirely, and you're left with 3x equals 12. So I'm just going to write 3x equals 12. And we'll solve that one in a second. And then over here, for the y-intercept, we can do the same thing, but with the plugging in 0 for x. If you plug in 0 for x, 3 times 0 is 0, so the 3x basically doesn't need to be written at all. So we can just cover that up and say, all right, negative 2y equals 12, and that'll be our other equation. Negative 2y equals 12. It cuts out a beginning step that you don't have to write because it will happen this way every single time if it's in standard form. So the two equations that we're dealing with are 3x equals 12 and negative 2y equals 12. All right, so let's go ahead and do those real quick. These are each one-step equations. We're just going to divide on each of these. So divide by 3. And then on the other one, divide by negative 2. 12 divided by 3 means that x equals 4. Over here, 12 divided by negative 2 means that y is equal to negative 6. So the x-intercept is at 4, 0. And the y-intercept is at 0, negative 6. All right, I would like you to try number 6 on your own. And just as a reminder again, the answers do not have to be whole number values. So that's a hint. They don't have to end up being whole number values to be correct. You want to check to see if you have the correct equations. They're on the board. I haven't solved them yet, but you're welcome to check. Okay, let's start with the y-intercept. Does anybody have it? Positive or negative? Negative 1. Good. So we, for the y-intercept, your equation would be 10y equals negative 10 because we plug in 0 for x. So this 8 times 0 can just go away, and you're left with 10y. And then negative 10 divided by 10 is negative 1. So y equals negative 1. So 0, negative 1 is the y-intercept. How about the X-intercept? Does anybody have that? -5/4. I like it. So, and if you got -10/8, that's correct. It just reduces. So here we go. Divide both sides by 8. So we got 8x equals -10 because we plug in 0 for y, and 10 times 0 is 0. So we don't need that at all. We can just write 8x equals -10. Divide by 8 on both sides. And x is equal to -10/8, which is not a whole number, but it does reduce to -5/4. So the x-intercept would be -5/4, 0. So those are the x-intercept and the y-intercept for number 6. So just a little bit of algebra. Any questions on those before we look at these last 4 where we have to do some graphing? All right. Now, whenever you are asked to graph using intercepts, you should expect the numbers to be whole number values. So you will not see anything like number 6 down here on 7 through 10. 7 through 10 will be much more like 4 and 5, because if you're being asked to put points on a graph, you're usually being asked to put points on actual like whole number locations on the graph, because those are a lot easier to find, especially when the grids are this small. It would be kind of mean if it was like, here, put 5/4 on this graph. You'd be like, it's too small. I can't get accurate with that. So expect these to end up as whole number values. All right, let's try number 7. So for the x-intercept on number 7, we're going to plug in 0 for y and solve for x. If you plug in 0 for y, the y goes away and you're left with x equals 3. There's nothing to do there. That's it. That's the answer. X equals 3. So the x-intercept is the point 3, 0. So we can put that on our graph. That's on the x-axis. So here's the x-axis. Here's the y-axis. So if we go over 3 from the middle of the graph to the right 3, 1, 2, 3, there is our x-intercept right there. For the y-intercept, very similar story. Y-intercept. Plug in 0 for x and solve for y. Well, that would just be y equals 3, because if you plug in 0 for x, it's just a y left over and y equals 3. So that would be the point 0, 3 for the y-intercept. And we've dealt a lot with y-intercept over the last couple of days. Start in the middle, go up 3, and there's your y-intercept. We've got 2 points on the graph. 2 points is enough to make a line. If you want to, you can put more points on here. You don't have to, but this is what the rulers are for today, these last 4 problems. Get everything lined up, draw your line through it, arrows at each end, just like we did yesterday. So instead of graphing using slope and y-intercept, we are graphing using x-intercept and y-intercept. So it's just another way of getting a line on a graph. So you don't necessarily have to convert standard form into slope-intercept form in order to graph. You can certainly choose to do that, unless the directions tell you to graph using a particular method. All right, any questions on that before we look at 8, 9, and 10? All right then, number 8, here we go. Number 8, the x-intercept means we're plugging in 0 for y and solving for x. So plug in 0 for y, the 5y goes away completely. So for the x-intercept, we're looking at 5y equals 20. No, sorry, -4x. Sorry, -4x. The y went away. -4x equals 20. How do we get x by itself? Divide by -4. Good. So divide by -4, which means x equals -5. Now you can write 0, -5 as your point, or you can just know that x equals -5 means I'm going 5 to the left on the x-axis because it's 5 negative, on the x-axis. So 1, 2, 3, 4, -5. There's the x-intercept right over there. Similar situation with the y-intercept. So we're going to write y-intercept, plug in 0 for x and solve for y this time. So 5y equals 20. Right, pretty small to fit this in here. They didn't really give us a lot of room to do this. All right, divide by 5. And what does y equal? 4. So the y-intercept is 4, which means on the y-axis, we're just going up 4 right from the middle of the graph. So 1, 2, 3, 4. And there's our y-intercept. And then we can line it up with our ruler and get our line through there with arrows at the ends. There it is. All right, so take a few minutes, work on 9 and 10. And then I'll have you check those answers in, let's say, 4 minutes. So 8:55. At 8:55, we'll check in. Oh man, they did something mean on number 10. How rude. Oh, the x-intercept on number 10, just so you know, is not a whole number. But if you think about decimals, it is a half. So just go halfway in between the 2 lines that you need to find on that one. I'll show you what it looks like as well. That's annoying. When? Oh. It's actually been found that one of the reasons why we went back to actually, was anybody here when we did that? Like in this actual building? I don't think so. What's that? So one of the reasons why we switched back is 2 years ago we did do a late start on Wednesdays. And like Monday and Friday were the same schedule, Tuesday and Thursday were the same schedule, and then Wednesday was its own schedule. So there were like 3 different schedules for 5 days. And we found that going back to same schedule every single day has actually been better for grades. Like people's grades are better when the schedule is consistent. I don't really know exactly what, the thinking or the reasoning behind that, but you know, like back in the day, it used to be all same classes, like, you know, every single day. And then it got switched up to the different period, like, you know, different bell schedules. And it went from pretty good grades to not as good grades. And now we're back to pretty good grades again. So for whatever reason, that consistency of the same schedule every day actually helps for student grades. So so we're sticking with that for now anyway, I'll tell you that much. All right. All right, here we go. Let's take a look. So number 9, what's the x-intercept on number 9? You can tell me. What is our x-intercept for number 9? Anybody have it? 5? Yep. How about the y-intercept? So x-intercept is 5 for number 9. What about the y-intercept? -3. Good. So here we go. Number 9. There it is. X-intercept is 5. Y-intercept is -3. Plug in 0 for y and solve for x. Plug in 0 for x and solve for y. 9x equals 45. 45 divided by 9 means that x equals 5. That's the x-intercept. For the y-intercept, we should have -15y equals 45. 45 divided by -15 equals -3. So the y-intercept is -3, and you can draw your line right through that. For number 10, like I said, that's a little bit mean on number 10. Does anybody have the x-intercept on number 10? So the y-intercept is -7. What about the x-intercept? Seven over 2, yeah. 7/2 is 7 halves, which is the same as 3.5 or 3.5. Now, practically speaking, 3.5 is going to be easier than 7.5 in terms of putting it on the graph. So basically what I did is I said, okay, I went to 3 on the x-axis, 1, 2, 3, and then I put my point basically halfway in between 3 and 4. I'm kind of annoyed by that because I don't like, as a math teacher, I don't like having to guess where to put a point on a graph. There are always ways to make things exact. And so this, to me, is not the most useful way of doing x-intercepts and y-intercepts, but it'll have to work. This one, I would actually say we should have done slope-intercept on this one, converted it to slope-intercept, and then done the y-intercept down here at -7, and then used our slope, which would have been, I think it's 2. Yeah, slope is 2, so 2/1. So I would have said we should have done y equals 2/1x minus 7, as opposed to this. But it works. It's not the most exact way to do it, but it works. All right, so that's it for the notes for today. Let's go ahead and get you going on your assignment.